In the Windward Plains, even the ground can feel temporary, and some monsters make that uncertainty their home. Balahara is the Windward Plains made flesh. Not the postcard plains either, not the clean midday vista where the grass stands still and the dunes look like geometry. Balahara belongs to the other plains, the ones that shift underfoot, the ones that breathe sand through your teeth, the ones where landmarks are provisional and the ground can change its mind about being solid at any moment. It is a leviathan that lives as though the land itself is a fluid medium, and once you accept that premise, its design stops looking bizarre and starts looking inevitable. At a distance, you do not read Balahara as a desert animal in the conventional sense. It does not advertise heat tolerance through tall ears, pale coloration, or the careful, miserly gait of something that budgets every movement. Instead, it looks like a creature that has refused the entire moral economy of aridity. Its body is long, serpentine, built for continuous motion, and its skeleton is described as flexible in a way that immediately tells you this is an animal that does not fight the substrate. It yields to it and then uses that yielding as propulsion. The Windward Plains punish rigidness. Balahara is an argument against rigidity. The most striking component of that argument is the carapace. Windward Plains lightning is not an abstract spectacle. It is a geological process. Strike-scarred fulgurite veins show up like brittle bone under the sand. Glassy tubes and nodules fuse from heat and pressure, sometimes exposed after storms and sometimes buried for seasons until the dunes peel back. Balahara is said to build its carapace out of fulgurite formed by lightning strikes, an act that sounds almost folkloric until you consider what fulgurite actually represents. The land's most concentrated expression of electrical violence turned into a durable, heat-tempered material. If you were designing armor in an environment where storms arrive hard and predators arrive harder, you would struggle to do better. The practical implications are immediate. A fulgurite carapace is not just protection against teeth and claws. It is also a shield against abrasion, because a sand swimmer lives in a constant grinding bath. Scales can handle a certain degree of wear, but continuous sand flow will erase a soft-bodied animal over time, the way it polishes stone. Fulgurite, being glass-like and mineral-dense, offers a surface that can take repeated particulate assault without simply sloughing away. It will chip, it will fracture, but it will not dissolve into the environment the way softer keratinous tissue would. That matters because Balahara is not a burrower that ducks underground and stays there. It is a swimmer, and swimmers are exposed. There is also the electrical question, the one people ask instinctively because they notice the lightning stone armor and assume electricity is involved. The truth is likely less theatrical and more biomechanical. The carapace being made from fulgurite does not require Balahara to use lightning. It requires only that the animal has learned to harvest and retain the byproducts of lightning's effects on sand. If the fulgurite plates are anchored into the skin by connective tissue lattices, then this becomes a case of external reinforcement. rather than internal elemental generation. You can imagine a juvenile acquiring small nodules and gradually accumulating larger plates as it ages, the way some animals accumulate shells or incorporate external materials for defense. That alone would produce size and rank variance in the population. Older individuals are literally better armored because they have had longer to build themselves. And then there is the head. Balahara's face is, in the most literal way, unsettling. It does not present you with the reassuring symmetry of visible eyes, nostrils, and the usual mammalian or reptilian cues that tell you where an animal is looking and what it intends. Instead, descriptions repeatedly emphasize the interior of the mouth. Multiple eye-like sensory organs inside, arranged along the edges of the jaws, often compared to tiny scallop eyes or photoreceptors. The jaw itself can appear tripartite, with the lower jaw and associated tissues able to split in a way that makes the mouth look like a three-part mechanism lined with short, saw-like teeth. This design choice is not arbitrary. It is what you would expect from a predator that spends much of its life submerged in sand. Sand is not water, but it behaves like a fluid under the right conditions. It transmits pressure waves, it muffles vision, it clogs conventional nostrils. It is hostile to exposed eyes. A sand swimmer that relied on external eyes would either have to keep them sealed most of the time or spend its life abrading them into blindness. So Balahara appears to do something far more elegant. It moves the key sensory organs into a protected cavity and lets the mouth become both weapon and sensor array. Those eye-like organs inside the mouth can be interpreted as light-sensitive patches that function when the mouth is open or partially open, but they need not be true eyes in the vertebrate sense. They may be photoreceptors tuned to detect contrast and motion in low visibility conditions, using the mouth opening as a window. That would explain why observers fixate on the mouth glow. Balahara's mucus is described as containing luminous bacteria believed to aid visibility while submerged and in low light conditions like sandstorms. In other words, the animal carries its own flashlight, but not as a beam, more as a diffuse internal glow that turns the mouth cavity into a lit sensor chamber. This is the sort of adaptation you see in environments where the world is functionally dark even at noon. In a sandstorm, daylight becomes a bright fog. Under the surface, the sand becomes a brown twilight. An animal that hunts from below does not need high-resolution sight. It needs the ability to detect edges, movement, and proximity at the moment of strike. A ring of photoreceptors around the bite zone gives you exactly that. It tells you when something has entered the kill radius. It tells you which direction the mass is moving. It might even help calibrate the jaw alignment when sand is swirling through the mouth. If the mouth is the sensory hub, then the rest of the head becomes a battering structure. Balahara does not behave like a delicate picker. It is described as creating quicksand traps for unwary prey, using its flexible skeleton and serpentine body, and it can also spit mud-like globules or a stream of mucus from the mouth. The mouth is soft tissue, yes, but it is also presented as a target that becomes vulnerable after expelling mucus. That implies a physiological cycle. Secretion buildup, expulsion, brief exposure of internal tissues, then resealing and reloading. The mucus matters because it ties three of Balahara's defining traits into one system: locomotion, trapping, hydration control. In a desert-adjacent environment, water monsters are not water monsters because they live in rivers. They are water monsters because water is a weapon. A high viscosity secretion can make sand behave differently. It can bind grains. It can change friction and shear. It can make a surface crust over and then collapse. It can create localized zones where the substrate acts like mud rather than dry sand. You do not need literal standing water to make quicksand, not if you can manufacture a wet, cohesive slurry on demand. That is likely the essence of Balahara's trap behavior. Antlions are an obvious analogy here, and the comparison has been made explicitly. Balahara's quicksand traps resemble antlion hunting tactics. Antlions create conical pits in loose sand. Prey slides in. The substrate becomes a self-maintaining prison as the victim struggles. Balahara appears to scale that principle up and weaponize it with movement. The key difference is that Balahara is not a stationary pit builder. It is mobile and muscular. Its traps are dynamic. This is where the flexible skeleton becomes more than a fun detail. If you want to create a sand vortex or quicksand pocket large enough to swallow a full-grown hunter or drag in an herbivore, you need to fluidize the sand. Fluidization is a real physical phenomenon. Granular materials can behave like liquids when agitated at certain frequencies and amplitudes. A serpentine body oscillating beneath the surface, coupled with a tail that functions as a drill, could generate exactly the kind of agitation needed to turn walkable sand into flowing sand. This also explains why loud sound disrupts it. Reports and guides consistently emphasize that Balahara relies on heightened hearing while submerged, and that sonic bombs or screamer pods are highly effective when it is under the sand. If the animal is navigating and hunting by pressure and vibration cues, then a sudden intense acoustic event does not just startle it. It blinds it, functionally. It overwhelms the sensory channel it is using to orient. That is important because it implies Balahara's whole hunting strategy is built around the physics of the substrate. A sand swimmer cannot afford to surface constantly to look around. Surfacing is exposure. Surfacing is vulnerability. Surfacing also gives away position. So the most efficient predator is one that can stay submerged and still track prey. That means vibration and sound, plus whatever low-light photoreception it can get when the mouth opens near the surface. Once you accept that Balahara hunts through the sand the way other predators hunt through water, its movement becomes readable. The tail is described as being used like a drill to swim through sand. You can imagine the scutes along the tail arranged in a spiral or ridged fashion, increasing traction against the grains. Where a snake in open air pushes against solid ground, Balahara pushes against a semi-fluid medium. The drill tail gives it purchase. The flexible spine gives it wave motion. The short limbs, when visible, are less for walking and more for bracing, pivoting, and rapid positional correction when it breaches the surface or climbs. And yes, it climbs. It is documented as being capable of clinging to walls and pillars, including those stone spires that rise like vertebrae from certain stretches of the plains. At first, this seems counterintuitive for a sand specialist, until you remember that ambush predators benefit from verticality as much as aquatic predators benefit from depth. A pillar is a periscope. A pillar is a listening post. A pillar is also a way to break line of sight when you need a breather, and a way to bait prey into moving around the base where the sand is already loose. If Balahara can cling and coil around such structures, it can turn static terrain into part of its trap architecture. This is also where its body plan reads like a compromise between a true aquatic leviathan and a terrestrial sand hunter. It retains gill-like slits in some depictions, suggesting an ancestry tied to water environments, but the primary modern function may not be respiration in water. It may be filtration and heat exchange. Sand is hot, abrasive, and particulate-rich. Having lateral slits that can close tightly, but also vent when surfaced, could help purge sand from airways or regulate temperature during high exertion. I do not claim this as confirmed, but as an inference consistent with the morphology described and with similar solutions in other burrowing or dust-exposed animals. Now consider Balahara's social behavior, because this is where it stops being a worm in sand and starts becoming a genuine ecosystem actor. Balahara is noted to work together in groups, sometimes described as packs of 3, and to overwhelm larger monsters such as doshaguma. This is a critical ecological detail. A solitary ambush predator is dangerous locally. A coordinated trio that can manipulate terrain becomes dangerous strategically. If 3 individuals can coordinate their sandpits, they can effectively turn a wide area into unstable ground. You can picture it as a moving patchwork of hazards. One swims beneath the surface to generate the sink. Another breaches to drive the prey's movement. The third waits to intercept the inevitable scramble. Against something like doshaguma, which relies on weight, footing, and group cohesion, undermining the ground is the cleanest way to neutralize size. You do not have to win a strength contest if you can make the contest happen on terrain that converts strength into liability. This also clarifies what Balahara's water element actually means in ecological terms. Water is not just a blight, it is friction control, a mucus that can be fired as globules, or a concentrated stream is not only for offense, it is an environmental tool. It can make a pursuer slip. It can turn a patch of sand into something that behaves like mud. It can coat the inside of a pit to reduce escape traction. It can even be used as a social signal if the luminous bacteria alter the visual profile of a site at night. Luminous bacteria, specifically, are a fascinating note because they imply a stable internal culture. The animal is effectively farming microbes in its mucus, maintaining a living bioluminescent layer. That requires chemical regulation. It requires that the mucus composition is hospitable to that bacterial strain and that the animal can prevent contamination or overgrowth that would compromise function. In the plains, where sand is full of microorganisms and spores, maintaining a consistent luminous secretion suggests robust antimicrobial components alongside the symbionts. It also suggests that the glow is not a random accident. It is selected for. The simplest explanation is visibility while submerged and in low light conditions, which is explicitly suggested. But you can go one step further without becoming poetic. A luminous mouth cavity could also improve depth perception at close range by creating a controlled light source and letting those photoreceptors detect how the light scatters off nearby surfaces. In other words, it could help the animal gauge distances inside a cloud of sand where external light is unreliable. If Balahara can see in its own mouth, then the bite becomes extremely precise. That matters because the bite is not just for puncture. The teeth are described as saw-like, arranged along multiple jaw segments. Saw-like dentition is excellent for gripping and for tearing under tension. In a sand trap, prey is often partially immobilized. The predator does not need a clean killing bite to the throat. It needs to secure purchase and then apply body weight and leverage. A flexible body can coil. A drill tail can anchor. A tripartite jaw can clamp from multiple angles. The sand itself can act as restraint. The kill, therefore, becomes a combined mechanical system. Substrate plus body plus mouth. This is also why Balahara can feel devious rather than simply violent when you observe it. It is not a straightforward charger. It is a terrain engineer. Even its breaches have an engineered quality. It emerges where you least want to step, and the moments where it is above ground often seem to be transitional, like a shark showing fin and then returning to depth. The fulgurite armor plays into this again, because it changes how other monsters interact with it. A soft-bodied sand swimmer would be easy to punish if caught out of position. A fulgurite armored leviathan can afford to take glancing blows while it resubmerges. It can allow a stronger animal to commit to an attack, then remove the ground from under that attack, then vanish. In that sense, the armor is not just defense. It is permission to take risks. This permission is crucial because Balahara's lifestyle is metabolically expensive. Constant swimming through sand is work. It is not gliding. It is pushing through a granular medium with high resistance. The reason aquatic animals can cruise efficiently is because water supports them and because their bodies are tuned for low drag flow. sand is not low drag. So Balahara must offset the cost by making its hunts high probability once initiated. Traps accomplish that. Cooperative traps accomplish that even more. From a physiological standpoint, you would expect such an animal to have extreme muscular endurance along the spine and tail, with dense myofibril packing and a high capacity for anaerobic bursts during breaches. You would expect reinforced connective tissue to prevent shear injuries during drilling locomotion. You would also expect specialized skin glands along the underside to secrete lubricating mucus that reduces friction and prevents sand from abrading the epidermis raw. None of this is stated outright in published descriptions, but it is the simplest biomechanical scaffold that makes the observed behavior plausible. Now place Balahara back into the Windward Plains food web, because this is where it becomes most real. The plains support large herbivores that move in herds and rely on open sightlines and stable footing. A predator that turns open ground into a sink breaks that entire defense model. Herding strategies assume you can run. They assume you can pivot. They assume the substrate is not going to swallow your legs. So Balahara is the kind of predator that forces herbivores to change their route choices. It likely shapes migration corridors by making certain dune fields too risky during certain times of day or season, the same way crocodile presence shapes river crossing points in our world. It also shapes predator behavior. You will notice that many surface predators avoid committing to fights near unstable sand. That is not fear. That is cost calculus. An injury on the plains is death. If Balahara can create a pit that compromises your stance, then a fight becomes roulette. Even a large brute might prefer to pull the conflict toward firmer ground, which means Balahara's influence extends beyond its direct kills. It changes where other monsters are willing to brawl. This is where Balahara becomes an influential species, in the same sense you framed for Quimatrice. Its impact is not solely what it consumes. It is how it makes the plains behave for everyone else. The interaction with Doshaguma is the clearest example, because it is explicitly depicted as something Balahara can overwhelm in a coordinated group. A Doshaguma troop is normally the sort of pressure that clears space through mass and persistence. But the troop model assumes stable terrain. If Balahara forces a Doshaguma to fight on a surface that cannot support its weight, then the troop's cohesion becomes a liability. Individuals bunch, footing collapses, and suddenly the bear's strength cannot translate into effective offense. A trio of Balahara can cycle pressure. One destabilizes, one bites, one intercepts. If the Doshaguma tries to disengage, it must cross the hazard field. If it stays, it sinks deeper. Balahara's relationship with smaller opportunists is likely equally consequential, but harder to witness directly, because it plays out fast and often below the surface. A sand swimmer that creates pits will incidentally trap small animals and invertebrates. This creates secondary feeding opportunities for birds and scavengers, and it likely creates a following behavior where certain species track Balahara routes for disturbed prey, the same way some birds follow large mammals for flushed insects. The luminous mucus could even become a visual cue at night, a faint blue glow under the sand that tells experienced scavengers and hunters that the substrate is active. Even in human terms, Balahara becomes a landscape hazard rather than merely a monster. Its pits can be used as environmental traps by others, and field observations emphasize that the creature's interaction with terrain is distinctive enough that hunters learn to read the environment differently when Balahara is present. The animal teaches you by necessity that the plains are not passive. There is another trait worth treating as biology rather than fight mechanics. The tendency for Balahara to expose a soft mouth interior after expelling mucus, creating a brief window of vulnerability. This implies a real trade-off. Expelling mucus is useful, but it requires opening the sensory chamber and revealing delicate tissue. So the animal must time expulsion when the risk is acceptable, or it must rely on the substrate as protection during the vulnerable moment. In practice, that likely means it prefers to expel while partially submerged, where only the mouth and a small section of head are exposed, and where the sand can immediately recover it if threatened. That would also explain why the mouth glow is most noticeable in low light and storm conditions. Those are the times it is most comfortable operating near the surface, because visibility is reduced for everyone else. Now return to the fulgurite again, because it is the detail that anchors Balahara as a Windward Plains endemic rather than a generic sand snake. If an animal is truly incorporating fulgurite into its body, it must have behaviors for locating it, handling it, and attaching it. That suggests either a developmental phase where juveniles actively seek lightning strike zones, or a social behavior where adults maintain and repair plates near known fulgurite deposits. Lightning in the plains is seasonal and spatially patterned. Certain ridges and open flats get struck repeatedly. If Balahara ranges overlap those zones, then the armor becomes a seasonal resource harvest, analogous to molting or mineral lick behavior in other animals. One could imagine older individuals with extensive plates controlling access to those strike zones, because armor acquisition would directly translate into survival and dominance. This would create a very plausible size and age stratification in the population. Younger Balahara would be more flexible and faster, but less protected, relying more on stealth and substrate avoidance. Older individuals would be slower to accelerate, but harder to punish, more willing to breach and climb, more confident in contested areas, and perhaps more likely to form the nucleus of those three member packs. It also makes the desert leviathan label stop being a contradiction. Leviathans are not defined solely by water. They are defined by the way they use their bodies to move through a medium, the way they treat the world as something to swim through. Balahara has simply chosen a different medium, and the plains have provided the raw material to make that medium viable. In the end, the most honest way to describe Balahara is not as a monster that lives under the sand, but as a monster that turns the sand into an organ. The Windward Plains are already prone to collapse, already shaped by storms and tides of grit. Balahara amplifies that instability into a weapon. It takes a landscape property and concentrates it, the way a hawk concentrates the fact that air can hold you if you shape your wings correctly, or the way a crocodile concentrates the fact that water can hide you if you keep your eyes at the surface. That is why Balahara feels so native to this place. It is not painted onto the plains as an encounter. It is a biological expression of the plains physics. When you stand on a dune field and you feel the ground shift under your heel, that is not just sand being sand. In Balahara country, it is a question being asked by the land. Are you standing on earth, or are you standing on something that wants you to sink? And when the answer comes, it comes from below, in a brief blue-lit opening of teeth and sensory eyes, a mucus bright mouth chamber closing like a trap, a fulgurite armored spine disappearing back into the moving substrate as if it was never there at all. Let the dunes settle, let the sand stay quiet, and let whatever is moving down there keep moving far from your path. Good night, hunter.